Hello and welcome to the 2.6 video. On this video, we're talking about the combinations of functions and composite functions. So when I say combinations of functions, what that means is that we are going to add, subtract, multiply, and divide functions. Okay? And then composite functions means that we're going to have functions within functions. So functions within functions. All right. So first things first, some notation that we want to talk about with regards to combinations of functions, adding, subtracting, multiplying, and dividing. So if I see this, if I see, say, f minus g of x, that really means that I'm doing f of x minus g of x. Okay, if I do f plus g of x, that really means that I'm doing f of x plus g of x. If I'm going to do multiplying, I'm going to do f times g of x, and that means that I'm doing f of x times g of x. And if I'm doing division, I'm doing f over g of x, which means I'm doing f of x over g of x. Okay, and so just kind of thinking of an example here, let's just let, if I let, say, f of x equal, the square root of x, and then let, say g of x equal, say, x squared plus 2, all right? If I were to subtract these, f minus g, what that would look like is this, all right? That would be, the square root of x minus the quantity x squared plus 2. Okay, and you can even simplify that a little bit further and do square root of x minus x squared minus 2. All right, if I wanted to add them together, it would be the square root of x plus x squared plus 2. Don't have to distribute your negative when you add, but when you subtract the quantity, when you subtract a function, you do need to distribute that negative. Okay, if I were to multiply these together, I would do square root of x times x squared plus 2. Okay, I'm not going to distribute that right now, but that's the idea. And if we do division, I would do the square root of x divided by x squared plus 2. So it's more or less just a lot of substitution, understanding, what all these things mean, and then transferring them, writing them like this, and then substituting those functions in, and then simplifying, okay? The next thing I want to do is functions within functions. So I want to do, talk about the notation of, say, FOG of x, and I want to do GOF of x. Okay, and if I do FOG of x, then what I'm really doing there is I'm doing f of g of x, meaning I am plugging in my function g into my function f. Okay, and then simplifying. All right, same thing with GOF. So g of f of x means that I'm plugging f, that function f, into g. So let's first find FOG of x. Okay, let's do that one. I'm going to do that one in green. So if I plug in g into f, that means I'm doing the square root of x squared plus 2, and that's equal to FOG of x. Okay, I'm going to do the other one in purple. Okay, and so g of f of x. So if I plug f into g, that means I'm doing the square root of x, quantity squared, plus 2, and that would be g of f of x. Okay, and that's the idea. And you can evaluate those and do all that. The one thing I do want to talk about is the domain. When you have domains of polynomials, your domain is going to be all real numbers. Okay. When you have a denominator like this, you want to set that equal to 0, and solve. Okay, when you have a square root function, you want to set the radicand, what's underneath the radicand, greater than or equal to 0. Okay, so in this case I would set 9x minus 27 greater than or equal to 0, because remember that whatever goes underneath the radicand has to be positive. So that's it in a nutshell. Let's go ahead and finish up these problems. Thanks a lot. Bye.